So good morning all and welcome back. Let us start data structure session of today's 21st September. So in previous lecture, we had seen infix to prefix conversion using stack. We had gone for a few exercises also. And then we had seen few more application, decimal to binary conversion, then recursive what is a recursive case and what is a base case we had seen, and how recursion helps us to solve a complex examples like n factorial, Fibonacci series, GCD, and so on. Right? I told you to go through this GCD and Fibonacci series recursive solution just for your practice. We discussed advantages and disadvantages of recursion also, and the main application of stack that we need to cover here, being a part of your syllabus, Tower of Hanoi, we started discussion on. So we understood what Tower of Hanoi puzzle is and what are the constraints, right? And based on that constraints, we had solved one example of Tower of Hanoi covering 3 disks, n equals to 3. So there were 3 disks. In first pole, we call it a source A, and the task for us to transfer all those 3 disks to the destination C. We can use road B as a spare if we need intermediate steps, then we can do it with spare road B. And these are the steps. 0 is the input. Then total we had gone for 7 steps, and we come up with the solution. On the right side, you can see all those 7 steps also. So you transfer first disk from the top only, A to C. So from source to destination. Then second, source to spare. Then third, destination to spare. Then fourth, source to destination, and so on. Now we are not writing any disk number or something, because at a time we will be able to transfer only one disk from the top only, right? So whatever is on the top of that road, we are going to transfer it. And from that understanding, we come up with this solution for 3 disks, right? Now at the end, I told you to focus on the 4 steps: 0, 3, 4, and 7. Red boxes I want you to focus on. 0, that's the input, given input, and that is the initial stage. Now from initial stage to stage number 3, focus on the red box, step number 3. What do you analyze here? 0 to 3, 3 to 4, and 4 to 7. Forget about 1 to 5, 6 intermediate steps. Just focus on red boxes. And what do you analyze here? Just give your analysis in the chat box. Whatever you think by looking at these 4 steps, whatever analysis you do, just write your findings in the chat box. What do you find? Okay, Keval is saying merging of disk can be helpful to data transfer. Okay, look, I am just asking you what kind of pattern you find here in this solution. We are only thinking on this Tower of Hanoi solution right now. We are not thinking on any application of other stacks or data transfer or storing data or anything. We are just focusing on this puzzle, and from these steps, what do you find for to analysis to solution for the solution of this puzzle. You can also focus here on the right side. 1, 2, and 3 step I have combined. Then fourth step is standalone, and fifth, sixth, and seventh step is combined. By looking at that part, can you find any pattern here? Well, let me tell you. Step number 1, 2, and 3. When you are done with step number 3, you can say that, look, there were 3 disks, and on step number 3, what you have achieved is you have transferred 2 disks from source to spare, A to B. Okay. And 1 disk remains in your source pole, source road as it is. So these 3 steps first are transferring 2 disks from source to spare. We are transferring 2 disks from source to spare. Then the fourth step, you can look on the left side image. In the fourth step, what we do, from third to fourth step, what we do is we transfer 1 disk which is there in the source. So we transfer that source to destination. So here we are transferring 1 disk from source to destination, right? And then from 4 to 7, 5th, 6th, and 7th step, what are we doing? Somehow we are transferring all those 2 disks, all those 2 disks which are there in the spare right now, from spare to destination, we are transferring it. How we transfer, we are not focusing on those steps. So 1, 2, 5, and 6, those 4 steps we are not focusing on right now. How do we do that? We'll find it out later on. But if we focus on these steps only, then this is what the finding we have. Do you understand this part? Just waiting for your response. Are you clear with this thing? Step number 1, 2, and 3. By doing those 3 steps, what do we achieve? We actually transfer 2 disks from source to spare. That's what we achieve. Then step number 4, what do we achieve? By doing step number 4, we actually transfer 1 disk from source to destination. And then 5th, 6th, and 7th step, what do we achieve? When we do those 3 steps, we again transfer two disks from spare to destination. That's what we achieve. So everyone clear with this part? Yeah, okay. So we actually want to focus on this thing now. When we were having 3 disks, okay, what do we do is we actually transfer 2 disks from source to spare. source to spare, we are transferring how many disks? 2 disks. Which means if I am having n disks, then somehow if I can transfer n minus 1 disk from source to spare, okay, somehow if I can transfer n minus 1 disks from source to spare, then there will be only 1 disk in my source node, and 1 disk I can easily transfer from source to destination, because by rule I'll be able to transfer 1 disk at a time from one node to another node. So source to destination, I can easily transfer that 1 disk, and once I transfer that, then the remaining n minus 1 disks which are there in the spare, because we had transferred from source to spare, so we have all those n minus 1 disks in the spare. Later on we are going to transfer it from spare to destination. Now how do we do that? We'll focus on that later, but this is what we can do, right? Somehow if I can transfer n minus 1 disk to spare, then 1 disk can be transferred from source to destination, and after that we will bring all those n minus 1 disks from spare to destination. So this is kind of a recursive step now. Why recursive? Because for n disks, this is what the solution you have proposed, but for n minus 1 disks, you can again think on the same solution. You can say that, okay, n minus 1 disk is there. I can say I'll transfer n minus 2 disks from source to spare, so that I can transfer 1 disk from source to destination, and then I'll bring those n minus 2 disks from spare to destination. So what are we doing? We are thinking on this n minus 1 solutions, n minus 1 disk solution recursively. Again, what you can think on is for n minus 2 disks, recursive solution you can do. So what exactly are you doing is, if you do have 5 disks, then you are first going for the solution of 4 disks. Now for the solution of 4 disks, you are going for 3 disks. For the 3 disk solution, you are going for 2. For the 2 disk solution, you are going for 1. And when you have only 1 disk, you have the solution. You can directly transfer it from one pole to another pole. So that is actually the recursive step. And what are we doing here? We are dividing our larger problem. Okay, for n disks, that's the larger problem. We are dividing that problem to the smaller sub problem, n minus 1, n minus 2, n minus 3, and so on. So we are dividing that problem and we are finding that solution. Once we have that solution, we will be merging all those solutions back and we'll have the final result. So merging process is not what we exactly need to focus on, because once we have the solution of n minus 2 disk, we'll apply it here. Once we have the solution of n minus 1 disk, we'll apply it here, right? So we apply those solutions and we'll have the actual solution for larger problem, right? So that's what the recursive step says. Recursive application says if you can solve n minus 1 cases, then you can easily solve the nth case, which will have only 1 disk, right? So by focusing on this statement, we can think on, if we can move n minus 1 disk from the top, from source to spare, okay, now during that process we will be using destination as an intermediary role, right? Then if you transfer it, then the bottommost disk you can easily transfer from source to destination, because that is the only 1 disk. And after that, what you do is you bring those n-1 disks from spare to destination again. And at that time, you can use source as an intermediary node. Fine. So this is actually this three statements actually leads to the recursive solution, recursive algorithm of Tower of Hanoi also. And that is this one. So in this solution, what you are doing is you are moving disk from one road to another road. So move is a function. Let's say we want to solve this for n disks. So first parameter is n, and then there are three roads: source, spare, and destination. Now we declare it as a character here because for source, spare, and destination we have a label A, B, and C, and to store those labels we call it character. That's it. Fine. Now the base case here is if your n is 1, if you do have only one disk, then it will be your base case. And in that case, what you do is you transfer your disk from source to destination, source and destination. And we are simply printing it on the output screen. So we move disk from source to destination. That is the output print. And that's the base case. Now, if your n is not equals to 1, then you will go for the recursive case. Recursive, which means you are going to call the same function, move. And in that, what we do is we do those three steps: n-1 disk, then 1 disk, and then n-1 disk again. So those three steps. And in those three steps, what we do, first step is source to spare. So now we need to focus here the sequence. Here it is source, spare, and destination is the sequence. Okay. So focus here. When I call my Tower of Hanoi for n disks with source, spare, and destination A, B, and C, then what we do is, for recursive case, we are going to call Tower of Hanoi again, right? First call will be n-1, second call will be 1, and the third call will be again n-1. Correct? Now the first call will be from source to spare. So A to B I want to transfer, and at that time I will use C, which is actually the destination, as intermediary road. The sequence is ACB, right? And that's what you will find here: source, destination, and spare. Have a look at here. Okay, the first call n-1 has source, destination, and spare. From this thing to this thing we want to transfer. So here source to spare we are going to transfer. And next thing, one disk will be transferred from source to destination, B as it is. So no change in that sequence: source, spare, destination. And the third one, we are going to transfer n-1 disks from spare, so B, to C, using source as an intermediary road. So spare to destination, source as an intermediary road. So I'll pause here for a while and you carefully look at these pseudocodes. Left side, it's a function pseudocode. On the right side, it is just for understanding part. Carefully read these two. Both are equal actually. Carefully read it, digest this information, and then we will go for the trace. Remember, sequence of this source pair destination ABC does matter a lot here. Okay, so be careful while you are writing this source pair destination sequence. If you change that sequence, then you need to be careful when you are calling recursive calls, recursive function calls. You need to be careful. So done. Should I go further? Okay, Parthiv is asking, where are we using spare in process of moving base disk? Yeah, in base disk, which is the middle one call, we are not exactly using it. But as we have the function with 4 parameters, we need to pass that as a parameter, but we will not be using it. Okay, Parthiv? You need to call a function with all parameters, but when you go to that function, you have a base case n equals to 1, so there is no use of spare there. Okay then, so now this is what we need to remember, and the important topic or the question now comes in your examination. If anyone wants to ask Tower of Hanoi, then there are two ways to ask. One is explain what is Tower of Hanoi with example, a simple short note kind of thing. So in that case, what you should do is you first explain what is Tower of Hanoi, then write the constraints. Okay, then give the solution for 3 disks, manual solution for 3 disks. Then you write pseudocode. Okay, now if it is 4 to 5 marks, then it's okay writing up to the pseudocode. If it is 6 to 7 marks, then after this pseudocode you need to give a trace also, which we will see now. Okay, so that is one question. Or another question one can ask is directly, it says give a trace of Tower of Hanoi when you have n equals to 4 disks. Okay, when you have 4 disks, then you give the trace. Trace means step-by-step solution. So that trace we want to have a look at now. But to find out that entire trace, you need to remember this properly. You need to remember this part properly. Now there is a hack in this one. If anyone wants to mug up, if you are remembering this part, you are understanding this thing, then you will be able to create this 3 function calls at any point of time. But if you are not in that position, then you can mug up also. Remember, I want you to have full marks here. And that simple trick is, if you go for source spare destination sequence, then your middle call will be in the same sequence, ABC, ABC. Whatever sequence is you have in your function call, your middle call will be the same one. Then on top of that, you exchange the last two, and on bottom of that, you exchange first two. This is how you can remember if you want. मिडिल फंक्शन कॉल सेम रहेगा, ऊपर पीछे के दो स्वैप होंगे, नीचे आगे के दो पैरामीटर स्वैप हो जाएंगे. Okay, then you'll be in a position to write entire trace. So with this one, let us go and find the trace for n equals to 3. Look, whenever you are going for writing a trace, what you should do is somewhere in the rough portion, you write two things. The first one is your pseudocode. So what we do here, middle one for n equals to 1 disk will have the same sequence. Upper one with n minus 1 disks will change the sequence of last two. And the bottom one with n minus 1 disk will change the sequence of first two. So one thing I want you to write is this one, somewhere in the rough part, okay, rough page or necessary page somewhere. That's one pseudocode for you. Next thing, you draw a tree kind of structure for n equals to 3. Okay, 3. So for 3, when you call this function n equals to 3, then there are three internal calls, n minus 1. So that will become 2, 1, and 2. For n equals to 3, n minus 1, 1, n minus 1. So that will be 2, 1, 2. Now when you have 2, again you go for intermediate or internal function calls. So 2 minus 1 is 1, 1, and 1. And similarly will happen here, 1, 1, and 1. Now when you have only one disk, it's a base case, so there won't be any recursive call, and we will stop here. So this is a function call trace. And from this tree, you'll come to know that how many steps you need to write in entire trace. Okay, so number of function calls you will find, and this is somewhere in the rough part, so that will help you to find out the entire solution. Now what we'll do is we'll start with this 3, first one. And for that, we'll call the first function Tower of Hanoi. And this is the initial function call, so it will be A, B, and C. Now we are tracing. So when we call this function, what is n? N is equals to 3, which means it is not a base case. Then what we should do is have a look at this tree. We need to have 2, 1, 2 function call. Right? So we need to have Tower of Hanoi 2, Tower of Hanoi 1, and again Tower of Hanoi 2. These 3 function calls we need to have. Now I keep some empty space in between. You'll just know why. So these are the 3 function calls. Now with this 3 function call, what will be the sequence of ABC? So now have a look at the pseudocode that we have written on the left. Middle will be the same. So if this is ABC, then the middle one will be ABC, right? Upper one will have ACB, and the bottom one will have BAC. Is this clear? अगर ये फंक्शन कॉल क्लियर हो गया तो इंटरनल सारे फंक्शन कॉल क्लियर हो जाएंगे. Are you clear with this one? Okay. So now we'll be focusing here only. Forget about rest two functions. Focus here, Tower of Hanoi 2. So Tower of Hanoi, again you are going to solve the puzzle with n equals to 2 disks, which is not a base case. तो फिर ये recursive call हो जाएगा अंदर, right? That's going to be the recursive call, and we are focusing here right now, this part only. This part only. So focus there, and what you should do is again you call 1, 1 and 1. So let me call that Tower of Hanoi 1, Tower of Hanoi 1, and Tower of Hanoi 1. So we need to have those three function calls. Then we should write the road sequence. So the road sequence right now, current sequence is this one, ACB, and that will be same as the sequence in middle one. So middle one will be ACB. Then ऊपर last के दो बदलो, नीचे आगे के दो बदलो. So I'm going to have that as ABC and CAB. So that will be the sequence of source, spare, destination. Okay. So I'm done with this part. This is only one road, so can be transferred from source to destination directly. Then we should focus on this remaining part. That is n equals to 2. So need to have again function calls. Tower of Hanoi, Tower of Hanoi, and Tower of Hanoi with 1, 1, and 1 disk. Do the same thing. Middle one will have the same sequence. So BAC, then BCA, ABC. So I'm done with the entire function trace. Okay, I'm done with entire function trace. I'm done with this last 1, 1, and 1 call also. So this is what the trace is. Now, if you just want to find out those steps, then how many steps will be there? You can calculate it with from this tree. From this tree, you find out how many number of ones are there. So 1, 2, 3, 4, 5, 6, and 7. So when we have 3 disks, there are 7 steps. We already know that, right? The number of ones are going to give you the number of steps. And those steps you can find from this function calls. Okay. When you have Tower of Hanoi 1, you write this source to destination step. Okay. This is going to give you all those steps. So the first one will be A to C. Second one will be A to B. Third one will be C to B. Fourth one will be A to C. Fifth one will be B to A. Sixth one will be B to C. And seventh one will be A to C. And you compare these steps with your solution, it will be same. So we found those 7 steps. And when you have your base case, if you are printing that source to destination letter, then you can also write your program, and that program is going to give you these 7 steps: A to C, A to B, C to B, A to C, and so on. And when you follow those steps, you'll have the solution for the Tower of Hanoi puzzle. So any query or confusion here? Make everything clear in your mind, because next step is your exercise. So make everything clear in your mind, understand everything. Right now, if you have any query, you can ask. But this is how we can find the solution of Tower of Hanoi. Well, if there is no query, then let's move on. So we had find this entire trace and entire solution for n equals to 3. Next question is your exercise. You need to find out entire trace and all the steps for n equals to 4. Now I want you to write down first, tell me how many steps you will require for this solution. Just give me the number of steps only. I'm not asking you to give me entire solution or entire trace. First, just give me the number of steps. How many steps you will require? Okay, someone says 14, 15, 9. Any other answer? Okay, 15 again. Do your math and tell me how many steps you will require here. If you want to find out those number of steps, as I said, you should draw this tree. And then from that entire tree, find out the number of ones. So for n equals to 4, we will have 3, 1, 3. Then for 3, we should have 2, 1, 2. And for 2, will require 1, 1, 1. And the same subtree we can have in this bottom part also. 2, 1, 2, 1, 1, 1, 1, 1, 1. And then find out the number of ones here. 1, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So we require 15 steps to have the entire solution. So do you find any relation between n and the number of solutions? Can you give me any mathematical equation by which if I can calculate the number of steps if I have value of n? When n is 3, there are 7 steps. When n is 4, there are 15 steps. Do you find any relation between n and the number of steps? Yeah, Anand is actually correct. 2 raised to n minus 1. Before going for entire trace, let's have that thing also. So when you have n number of disks, if there is only one disk, you can directly transfer it from source to destination. So one step. If you have 2 disks, then you'll require 3 steps. 3 disks, 7 steps. 4 disks, 15 steps. 5 disks, then you'll require 31 steps. So those are the number of steps. And you can find a relation between that n and number of steps, like 2 raised to n, 2 raised to n minus 1. That's the equation. So here we can say, oh, 2 raised to n minus 1, you can find those number of steps. So 2 raised to 4, 16 minus 1 is 15. So we require 15 number of steps. 2 raised to 3, 8 minus 1 is 7. We require 7 number of steps. So likewise, you can calculate those number of steps here. Now actually, this is the last topic in your stack. What we have seen till now, we've gone for stack definition, concepts, and its operations. We had implemented stack also. Then we had gone for applications of stack. So police expressions, which is infix to prefix, infix to postfix expressions. Its compilation and evaluation both. And the last one, we looked at Tower of Hanoi, right? Still, we are going for Tower of Hanoi n equals to 4 trace. But once we are done with that, next thing from the next lecture, we will go for Q. So from next lecture onwards, we will start Q. Simple representation of Q, then Q operations. And then we will look at the types of queues: simple queue, circular queue, double-ended queue, priority queue, and so on. And at the end, we'll see few applications. So that will be the next step once we are done with n equals to 4 trace. So that's the upcoming lecture content. Coming back to this thing now, n equals to 4. Now I want you to try for that trace. Tower of Hanoi with 4 disks and ABC source spare destination function call. You trace this one. Try to have that solution. I give you a few minutes, and At the end of this session, I'm going to give you the entire solution. You can also have these ABC sequence on a tree directly, like I'm writing here. If you have time, then you can write this thing also, so that you need not to keep space, empty space in between when you are tracing the entire thing. You can verify the sequence, and if I'm making any mistake at any point of time, you can tell me. So this entire trace will give you the entire solution, 15 steps solution for Tower of Hanoi when you have 4 number of disks. There are a number of uh, games, puzzle games available on Play Store with Tower of Hanoi. And in that game, you can choose number of disks for you, and then you can try for the solution, play that game. Now, if you already know this algorithm, this solution, then you will be in a position to solve 10 disks also. Definitely, there will be number of steps larger, but you will be in a position to solve that thing. Others will not be in a position to solve that thing. This exercise is going to help you for the trace of any function call. You'll understand how recursions are being executed. If you are done, you may post your solution in the chat box also. 15 steps. Anyone completed? Well, we are about to end our session here, so I'll leave you with this question. Give it a try. Go for the trace of Tower of Hanoi when you have n equals to 4 disks. Almost entire solution is there on your screen right now. How you call function, so pseudocode, and what are the number of calls, entire tree. And with that tree also you have the sequence of source pair destination ABC. So you can verify your answer with this tree. So we'll stop here. In next lecture, I'm going to give you the solution for this tower of Hanoi n equals to 4 trace, and then we will start Q. Okay, as I said, we are going to start Q in the next lecture. That's it for today, and thank you for joining this session. If you have any question, you can ask, or else you may leave this meeting now. Thank you.